Okay, welcome back. Today, we're going to start chapter 5. We're going to take a look at function composition. The idea of function composition is that we want a way to combine functions. In this case, we're going to be plugging functions into other functions. What this looks like is if I have a function f, let's actually do it this way. So let's say I have a function f that works on a variable x and turns it into f of x. I then plug the output f of x into a second function g. This will give me g of f of x. So the output of the original function becomes the input of the second function. In other words, the original variable passes through two functions back to back. Now, because of the way that we write functions, the function that the variable passes through first ends up being written on the inside. So we'll end up with an inside function, in this case f, and an outside function, in this case g. And always the inside function is evaluated before the outside function. There is additional notation that you can use, which looks like this with this circle. And you would read this as g composed with f. Now, this notation is more helpful at upper levels of math, but more confusing at this level. So I prefer personally this notation because it's easier for me to think about an inside and an outside. However, in either case, it's very important to know that perhaps counterintuitively, it's the right-hand function that's activated first, then the left-hand function. With the inside-outside notation, that is a little bit more clear than it is with the circle notation, which is why I will prefer the inside-outside notation. But we will certainly want to be able to recognize both. Let's take a look at a couple of specific examples. If I have f of x is 4 minus 3x and g of x is x squared plus 1, we would like to find f of g of 2, g of f of 2, and then g of 2. So in the other notation, this would be f circle g, g circle f, and g circle g. It is perfectly okay to compose a function with itself. Let's go through each of these. So for f of g of 2, g of 2 is equal to 2 squared plus 1, which is 5. F of, let's do it like this. F of g of 2 is equal to f of 5. I took the input from, or the output of the original function and made it a new input. So f of 5 becomes 4 minus 3 times 5, 4 minus 15, negative 11. We can do the same thing in the opposite order. Let's try g of f of 2. In this case, we'll start with f of 2, which would be 4 minus 3 times 2, which would be equal to 4 minus 6, negative 2. And then g of f of 2 would be equal to g of negative 2, which would be negative 2 squared plus 1. 4 plus 1 is equal to 5. We could also find g of 2. We already found that g of 2 was 2 squared plus 1, so 5, which means I need g of 5, since this piece is equal to 5. 5 squared plus 1, which would be 26. Now, you don't just have to take functions with a numerical input. It's also okay to have a variable. In this case, we'll take a look at what the composed function as a whole would look like. In other words, we have over here f and then g. We would like to find the composed function, which would be g of f. So by putting the functions together, we can find a single rule for the composition. Now there's two ways to do this, inside out or outside in. Let me show you both ways with this first example. So with f of g of x, I could first say, okay, that means I have f of, and I say g of x is x squared plus 1. That means that I have 4 minus 3 times x squared plus 1. Or I could say I have f of g of x, which would be like 4 minus 3 times g of x, which would be equal to 4 minus 3 times x squared plus 1. You see that we get the same result no matter which way we go about it. It's just, do I plug in the inside first or the outside first? As I'm going about this, what I like to do is leave myself these parentheses first as I'm writing through it if I'm doing the outside in method, and then just fill in the parentheses last. So I would say f is 4 minus 3x. So f of g is 4 minus 3 times g, where g is going to be these parentheses. And then I fill the parentheses in at the end. So in this case, doing g of f of x, I could do either method here. Let's say that would be f of x squared plus 1, which would be 4 minus 3x squared plus 1. Again, if we needed to simplify because we were going to do something with this function, you would simplify. But if I don't ask you to simplify, you don't have to. And then g of x would be x squared plus 1. It would be, excuse me, g of x squared plus 1, which would be x squared plus 1 squared plus 1. Now, the idea for domain when I'm talking about a composite function if I'm just thinking about a single function, then I have a domain and a range. But when I add in a new function, the input of g has a rule too. So on its own, I have to consider the domain of g. G has a domain and a range. But now what I see here is that the range of f is equal to the domain of g. So in other words, the output of f has to be able to be an input of g. So that means that we have two considerations to worry about here. Number one, x must be in the domain of f. And then number two, f of x, what I obtain when I take x through the first function, must be in the domain of g. We can summarize this. Oh, I guess I didn't copy the theorem over. That's the idea here. My original input x must be in the domain of f. f of x must be in the domain of G. So going through an example here, I have a couple of functions, 2x over x squared minus 4, and then square root of 1 minus x. We'd like to find first the domains of each of the original, just as a review, and then put them together to see how their domains fare when I compose them. Let's first start with the original function f. In f, I see division, so I know x squared minus 4 cannot be equal to 0. That means x squared cannot be equal to 4, and x cannot be plus or minus 2. In other words, the domain is equal to either the real numbers except for negative 2 and 2, or in terms of what my open math wants, negative infinity to negative 2 unioned with negative 2 to 2 unioned with 2 to infinity. For G, square root of 1 minus x, that means that the inside 1 minus x must be greater than or equal to 0. This will quickly give me 1 is greater than or equal to x, and the interval 1 comma, 1 is greater than x, which means x is less than 1. So this should be negative infinity, comma, 1. Now let's go through and find each composition. For g of f of x, first I must follow the rule for f, because that is what x gets directly plugged into. So that same rule is as before. X still cannot be plus or minus 2. And then I have the rule for g. So this is the rule for f. And then in this case, I've got a rule for g. The rule for g says that f of x must be less than or equal to 1. Remember, f of x is what gets plugged into g. And the rule for g is over here, that x must be less than or equal to 1. But in this case, I'm not plugging x into g, I'm plugging f of x into g. So f of x must be less than or equal to 1. Well, in order to find this, we'll need to go ahead and set up a number line because we're setting up a complicated inequality here. So that means that I will have 2x over x squared minus 4 is less than or equal to 1. So this will give me, let's see, 2x is less than or equal to x squared minus 4. X squared minus 2x minus 4 is greater than or equal to 0. This does not look like it's going to factor, so we'll use quadratic formula. 2 plus or minus square root 2 squared minus 4, 1 negative 4 over 1 squared. Okay, so this part here is negative, so there's no solution. So the only things that need to go on our number line here are negative 2 and 2. Both of which are undefined in the original. And then we will take each of these things and plug in to 2x over x squared minus 4 minus 1 to see whether it is greater than or less than 0. It should be less than in order, so we're looking for the negatives. So let's take some test values of negative 3, 0, and 3. So plugging in 0, let's start with negative 3. Let's do this in order. So that'll be negative 6 over 9 minus 4, 5 minus 1. That's certainly going to be less than 0, so we'll need a negative. Then at 0, we will be plugging in zero, so that'll be 0 over negative 4 minus 1 is negative 1, again, less than 0. We've got us a negative here. And then finally, we'll plug in 3, so that will end up being 2 times 3 over 5 minus 1, so that's 6/5 minus 1. That's greater than or equal to 0. So in this case, we end up with a positive. So what we are looking at then, we know x still cannot be -2, but it also cannot be larger than 2. So the intervals that we're looking at are this one and this one, which will be the interval of -infinity up to -2, unioned with -2 up to 2. Let's try another example. We want to do f of g of x. So for f of g of x, that will be the rule for f says that, we start with the rule for g because that's on the inside. The rule for g says that x must be less than or equal to 1. And then the rule for f says that g of x cannot be equal to 2 or -2. Now, we shouldn't have a problem with g being negative because g is a square root. So we can immediately cross that one out from our consideration. It's still something that cannot happen, but it's not going to happen, so we don't have to worry about it. So we'll just have to make sure that square root of 1 minus x is not equal to 2. That means 1 minus x cannot be equal to 4, and x cannot be equal to -3. So that means that we will have the numbers less than 1 except -3. So we could either do -infinity to 1 excluding -3, or in terms of what my Up in Math would like to see, -infinity to -3 unioned -3 to 1. Let's do one more example. We'll do f of x. We'll need a little more space for this one, so we'll just copy ourselves down that f of x is equal to 2x over x squared minus 4. In this case, we will go ahead then and we will say, okay, the rule for f says that x cannot be plus or minus 2. And then we have a rule for f of f, which says that 2x over x squared minus 4 cannot be equal to plus or minus 2. So we'll set up each of those. If 2x over x squared minus 4 is equal to 2, then 2x is equal to 2x squared minus 4, which means x is equal to x squared minus 4. 0 is x squared minus x minus 4. Is that going to factor? It does not look like it. Yeah, no, that won't work. So let's check quadratic formula. 1 plus or minus square root for 1 -4 over 2. So this would be 1 plus or minus the square root of 17 over 2. And then we would also do the same thing with -2. So we would have 2x is equal to -2 x squared minus 4, which means -x would be equal to x squared minus 4. 0 is equal to x squared plus x this time, minus 4. Again, this won't factor, so we'll do quadratic formula. This time it's -1 plus or minus square root for 1 -4 all over 2, giving us a very similar answer, -1 plus or minus the square root of 17 over 2. So that means we have 4 restricted numbers from this new piece and 2 originally. So we would say that the answer is all real numbers except -2 and 2, 1 plus root 17 over 2 and 1 minus root 17 over 2, and also negative 1 plus root 17 over 2 and negative 1 minus root 17 over 2. I won't go ahead and write out what my open math would be looking for, but these would be the excluded values and we would line them up for intervals. That's all we've got for today. I'll see you next time.